right, I think we can start. So please take a seat, and we will start in a second. So hello everyone. My name is 𝙁𝙁𝙬 Kędzierski, and I have a big pleasure to meet you all on our next AWS User Group meetup, number 63. So yeah. This is also like a special day today, so I would like to wish best for all the women that came. So that's nice. We have like a quite big representation. That's really cool. So if you didn't take the beer yet, please take it from the table or from the fridge. There is a cold beer, non-alcoholic and alcoholic. There will be a pizza later and so on. That's the information that you probably were waiting for. But I just wanted to say a few words about where we are and about our partners first. So we are in the Grand Parade office, as you probably know. So thanks for having us. And we have also with us partners that I wanted to mention as well. We have Łukasz and Tomek. So you want to say a few words as well, right?
Yeah, sure. My name's Łukasz, as you said, and I'm working for ROECS. We are a distributor of AWS and NetApp, and today our colleague, she will be online, will tell you about Spot solution which can optimize your AWS consumption and etc. And please remember that here we've got some awards for active users, and it is for on-site active users and for online who will just fill out a survey that will be at the end. There will be a QR code that you will be able to scan, and for 21st attendees who will fill it up, there will be also some awards. Okay, Tomek, maybe a few words from your side.
Okay, thank you, Łukasz. My name is Tomasz Sochacki. I am from Trek to Summit company. We are partner from AWS and NetApp. We make some project about migration to the cloud.
One more thing, or last thing, Karen, who will provide the presentation about the Spot, she's, I would say, technical and sales. So if there will be any technical questions, maybe let's leave it for the next meeting, especially in this survey. We will ask you, or there will be a question, are you interested in some technical workshops and etc. So please just write that you are interested in. Okay, that's all from my side. Yeah.
Right. Thanks a lot. So I have one more thing to add. There will be some gifts that you can get. So there are two ways how you can do it. First, be active. For the most active people here and also online, we will give you some gifts, and there will be also a quiz at the end. So there will be a QR code that we will show in a second, and just basically listen, and you will be able to know the answers. And we will choose few persons who will actually get some gifts based on the correct answers to that quiz. All right, thanks a lot. Just give me 1 second. Just we'll need to turn the screen on, and we can start our first presentation.
Hey everyone, can you hear me?
Yes, just give us 1 second. We're just going to connect the screen and we'll be fine.
No problem.
Now, okay. Welcome, Karen. Now we can hear you and see you. That's perfect. Without further ado, we can start the first presentation. Thanks.
Great. Thank you for this intro, and nice to meet you guys. Thank you very much. I wish I could be there live. I wish I could eat pizza as well there, but I couldn't attend, unfortunately. Hopefully next time. So it's very nice to meet you. Thank you very much for attending. I'm Karen. I work at Spot as a channel development manager. I joined Spot by NetApp about a year and a half ago. So I work with partners around the globe, and I work close with Arrow and Trek to Summit as presented. And today I would like to discuss about Spot and how Spot could help you guys to reduce your costs and to optimize your environment. I'm not exactly sure how much of the audience is already using AWS on a public cloud, but I would assume that most of the audience, and if you're still on premise, that I will assume that you're planning to migrate as soon as possible to the cloud. So let me share my screen, and please feel free to engage and to ask questions and to interrupt me in the middle. Go ahead. I'm just sharing it. Okay, great. So just to make sure, you can see my full screen right now, right? Spot by NetApp More Cloud. Okay, I assume that you.
Yeah. Yes. So we can see you and see the screen as well.
Okay.
Perfect.
Great. So let's start with a short overview of a snapshot of Spot, because maybe we're not that familiar within the audience here. So Spot is a cloud optimization and automation platform. Basically, as I briefly said, we're able to reduce up to 80% of our customers' compute costs. But it became more than this. I mean, besides cost reduction, Spot is helping our customers to do more in the cloud, to utilize their resources better, to innovate faster, to deploy workload faster, to do what they do better by using Spot by NetApp. They grow faster by using Spot. So basically, we started 7 years ago. Actually, I think that it's already 8 years ago in 2015. And now we're at the point where we have about 3,000 customers all over the globe. We're running billions of hours on Spot instances and Arise on a monthly basis. We're saving hundreds of millions of dollars on a monthly basis. And as I said, we're growing day by day. We're expanding massively. And basically we started we are a super cloud focused, and about 2 years ago, we were acquired by NetApp, which I assume that you're familiar with. So NetApp did storage, and they acquired Spot as part of the transformation to the cloud world. So now we're a part of NetApp, and we're getting some really good tractions out there. So this is, for example, a GigaOM radar report that came out earlier this year that describes the cloud optimization market. So they were naming us as the only outperformer, by far the leader in this region. I think that we're the only vendor that provides a coherent, comprehensive offering around cloud ops and cloud optimization. So it's really cool. We are very proud of the results. Briefly going over another report that was conducted in 2022 by IDC. So they were exploring the benefits of using Spot by NetApp. And here you can see some of the results. So as you can see, almost 700% 3-year ROI, about 41% more efficient IT infrastructure staff quoting, we don't need to scale our stuff up. I think that it's every DevOps or FinOps manager dream to hear this sentence, right? Faster time for productive DevOps team, more efficient provisioning, faster IT agility, faster time to market. I can go on and on. I can share the full report later on for whoever is interested. And this is a very small sample of our 3,000 customer base. So as you can see, we have customers anywhere from the biggest enterprises in the world, such as VMware, Sony, Samsung, IBM, Intel, AstraZeneca, Nike, AT&T, Verizon, and can go on and on, all the way down to a 10-employee startup. So basically, wherever you are in this scope, whether you're an enterprise or whether you're a cloud native, a startup, a unicorn, we love cloud natives, wherever you are, as long as you're using a public cloud, AWS, also Azure and GCP, we would like to work with you. We would like to provide value for you. This is what, I mean, this is the only requirement that we ask, that you would be on AWS. And this is the main problem that I would say that we're trying to solve. And actually, this is not even our slide. We stole it from AWS. As you can see, the logo here, it's their data. So as you can see, whenever customers migrate from on-premise to the cloud, if it's one-to-one, they see that their IT consumption, their cloud consumption has doubled. And the reason is because cloud per running hours is simply much more expensive than actually owning your own data center. Cloud has its own benefits, right? But it's much more expensive. Customers see that their costs are exploding unexpectedly. They do not know how to manage it. And then they will start maybe right-sizing and start modernization. Maybe they will get rid of some idle resources until they get to the point where they're anywhere here, if you can see my my mouse, where they're cost-effective, well-architected. Now, this time frame could potentially take sometimes 3 to 4 years. So what we do, we meet them at the point where they already migrated to the cloud, anywhere in this time frame, whether it's at the very much beginning or anywhere in the middle. And our mission is to bring them as fastest and directly to the point where they're already automated, cost-effective, well-architected. And by that, we're helping them to save all the years of struggle and pain of trying to reduce costs, and we're maximizing the results out of this. Now, customers could potentially say that it's easy to reduce costs, right? I, as a customer, as a company, I have my own DevOps and FinOps team. I don't need any third party. I can do it by myself. This is why I have my employees, right? So they would say it, and then they will start Googling cost management on AWS Engine, for example, and they will find only a bit more than 6,000 articles out there. And if you expected by coincidence any differences in Azure, for example, so wrong, pretty much the same, more than 4,000 articles you can find. So the amount of practices around cost management in the cloud is insane. There's so many tools out there, so many manual processes. Customers understand that migrating to the cloud is not an easy button that they thought it would be, to press an easy a button. They get into an overdrive of complexity, and what we do is help them to simplify and to automate a lot of this burden. In addition to the fact that it's really hard to manage cloud on your own, we can equivalent cloud to your room. So if you're like me, I wake up on a Monday morning after the weekend, and my room looks like a nightmare, right? I mean, everything is super messy. And then I will start cleaning, and then I will neat it, and it will tidy the room. And on Tuesday, it will be perfect. But the problem is that then comes Wednesday, right? And the mess is there all over again. And it's as if nothing has happened between Monday to Wednesday. And this is the exact thing with cloud. So by understanding that cloud environment is constantly changing, that it's constantly scaling up and down, and that optimizing the environment is not a point in time exercise. It's not a point in time event, but it's a continuous exercise. We are extending your existing CI/CD pipeline, and we're adding CO, continuous optimization, continuous automation. So these are the two key costly problems around cloud, that it's very hard to manage, as we said, and it's a continuous exercise. It's not a point in time event. Are there any questions so far before I drill down a bit more? Or should I just move on? Okay, I'll move on, and if there are questions, so let me know. So let's talk a bit about the pricing models that AWS, where the pricing models that you can buy instances from AWS. I assume that we're all familiar with them, but just to make sure that we're all on the same page. So let's start with on-demand. You can buy on-demand is the most expensive pricing model from AWS, but it's the most convenient one. I mean, customers migrate to the cloud because they would like to pay on demand. They would like to pay only for what they need and what they use. But as we said, the problem is that it's double the price than actually being on premise. So then AWS came with the offering of commitment plans, where you can buy cheaper instances as long as you commit for a 1-year commitment, 3-year commitment. But the problem is that if you think about it, it actually contradicts the entire idea of moving to the cloud. I moved to the cloud not to be committed, but now I'm committing because I wanted to pay less. So this is a bit of a problematic. Last option that AWS offer is spot instances. So spot instances are the cheapest, is the cheapest option out there. It's up to 90% cheaper than on demand, but the problem is that they are the leftovers. So what it means is that AWS can decide to take those instances away with up to 2 minutes notice, and give them to someone give it to someone that is willing to pay on demand. So basically, you have no SLA for these instances. You can't really rely on them. They are the riskiest, and this is why most customers choose not to purchase spot instances. And if they do, they would choose it only for low environments, non-mission critical environments to deploy. And this is where Spot by NetApp gets into action. So basically, whenever we just meet the customer at the very much beginning, usually his environment would look like this. Even though on demand is the most expensive, as we said, it's the most convenient one. So the majority of the environment would be on demand, about 60-70%. The customers might have some commitment plans that they purchase on their own. Usually, we will discuss about it later on, but usually it will be in a very low coverage, very few commitments that they have purchased because it's very complex to do it on your own. And they might have some spot instances that they bought, again, maybe for low environments. Most of them do not even want to hear about spot instances because, I mean, they don't want to handle this burden. What we do is the exact opposite. So we will shrink on demand as much as possible, and we will maximize the usage of spot instances. But instead of 0% SLA that you get for spot instances from AWS, we ensure you that you can run with spot instances on a 99.99% SLA that we guarantee for the capacity, which means that we guarantee that you will always have the capacity that you need with spot instances. So now we're drilling to the first product that I would like to talk about, and it's called Elastic Group. So Elastic Group, again, it was the first product that was launched 8 years ago, and we like to call it our auto scaling groups on steroids. So the idea of how we leverage spot instances is hidden here. So basically, throughout the 8 years that we exist, we continuously collect data about the behavior of the global spot market. We constantly monitor the market 24/7. We're able to identify trends and patterns on real time. And thanks to that, we have created a machine learning algorithm that enables us to actively predict future interruptions. And what it means is that if instead of up to 2 minutes notice that AWS will offer you now, that will notify you now that they're going to take your instance, we can get notified with at least 15 minutes in advance. It could be up to an hour that AWS will take your instance. And by that, we have enough time to proactively identify a healthier market, drain all the connections, and reattach it to the new one in a graceful manner with no interruptions, no downtime, as long as your environment is stateless, meaning as long as your environment can bear a slight reboot. So as you can see here, basically we're building a heat map based on our customers' availability zone, region, instance type, instance size, operation system, the customer defines the bulk that we can choose spot instances from. And within this bulk, we score every instance from 0 to 100. Every instance that is scored 70 and above, we consider to be reliable, and we're going to use this instance. Every instance below the score 70, we're not going to use because we want your application to be as stable as possible with no interruptions. And this is why we're not going to take any risks in choosing something that is below 70. So whenever we know in advance that AWS is going to take your instance, we will spin up the one with the highest score, meaning that is the one that is least likely to get any interruptions. So sometimes we can run even for 11 days on the same spot instance, which is like massive. So the cool part is that even if we know that AWS is going to take your instance, but the entire metrics here is going to be colored red, which means that nothing has the score 70 and above, nothing is applicable for us to use, and in the most simple words, we're stuck. So we have the ability to fall back to on-demand temporarily until we will find again an instance that is scored 70 and above and it's available again, and immediately we will move back again to spot instances once the market is available. And by that we can maintain your infrastructure, we can provide you this 99.99% SLA. And what it actually means is that you can run production with us, with Spot by NetApp, with spot instances. Our own Spot by NetApp infrastructure production runs on spot instances. We have several customers, unicorns, that almost 100% of their workload runs on spot instances. So the idea of the technology is that we're constantly ahead of AWS. Before AWS ever has the chance to notify you that they're gonna take your instance, we're already ahead of them, and we can terminate the instance before they even notify us. And by that we're able to maintain the infrastructure, again, you can run not only non-mission critical environment, but only production and basically your entire environment as long as it's stateless. So again, with this technology, we have Elastic Group, and these are the common use cases for Elastic Group. So everything that is running behind load balancer, everything that is running on auto scaling groups, bad jobs, big data, Jenkins runners, all of these are the common use cases for Elastic Group. Now we have, as you know, containers are slowly growing and conquering the world. So we have a younger brother for Elastic Group called Ocean, and Ocean is the same as Elastic Group, only for containerized environment. So as containers conquer the world, Ocean the same in our world. So Ocean is like the number one seller in our like portfolio right now. So Ocean, as we said, is a serverless experience for Kubernetes or every other control plane, whether it's ECS, EKS, AKS, GKE, whatever it is, Ocean knows to integrate with your existing control plane. And it is comprised of 3 layers. The first layer, infrastructure provisioning and pricing, is exactly the same as Elastic Group at the heat map that was shown in Elastic Group. So it will take under consideration each instance requirement. It will know whenever to spin up a new instance, which instance to spin up, to drain all the connections, to be ahead of AWS. Only with this layer, you can reach to 70% of savings. Now, there is another layer that does bean packing to the pods and the nodes, which means imagine a Tetris game. So this layer can compress as many pods as possible on the nodes, which brings to a much higher node utilization. Usually, whenever we speak with our customers before they use Ocean, we hear that their node utilization is around 40 to 50%. With this layer, you can reach to 90, even 100% of utilization, which of course leads directly to another reduction in your costs. This layer has another feature called headroom. Whenever you have sudden spikes in your application, so instead of deploying another node that can cause delays in the performance, this feature is a reserved capacity that allows you to scale up much faster and without any pods in pending state. And last layer is about the application itself. Here we provide you a dashboard where you can see your pod's allocation versus your pod's actual utilization, because we know that DevOps teams over-provision pods to guarantee everything. And with this dashboard, you can see what you allocated versus what you actually used, and then you can decide. It's up to you. You're the application owner. We provide you the dashboard as recommendation. You can decide to reduce initially the pods that you're allocating based on the actual usage. And again, it's another way to reduce cost, to save more out of the consumption. Now, this is an overview of Ocean. Ocean has a lot of other cool automations that I'm not gonna discuss right now. But the main idea about Ocean is that the cool part about Ocean is that whenever we speak with our customers, with our existing customers, so they keep saying that they came because of the cost reduction, right? I mean, Ocean could reduce massively up to 80%, as we said, but they stayed because of the automations. Eventually, our customers' DevOps life are much easier after using Ocean. They don't need to take care of the burden of the management of the infrastructure. We took this away. We put a lot of automations behind it. So basically, now they have time to focus on their real job and not to take care of this. So this is what I mean. This is if this even wins the reason of the cost saving. Their life are much easier and more simple because of Ocean. So this is Ocean. Last product that I would like to talk about today. I mean, we have, if you're gonna review our website, we have about 10 products out there, but these are the most mature and the core products that I would like to focus on. So last product would be from a FinOps perspective. Until now, we spoke from a DevOps perspective, Ocean and Elastic Group from a DevOps perspective, as I said. And 𝑒co is a bit different. So as you can see here, this is the customer's cloud journey. Usually, whenever customers just migrate to the cloud, usually they have legacy, stateful, monolithic type of workload. And this is where 𝑒co could provide value. So as we said, 𝑒co is our FinOps fully managed by us service, where we leverage the commercial offering that AWS offer in regards to commitment plans. So as we said, you can buy cheaper instances, cheaper than on demand, but as long as you commit for a 1-year commitment or a 3-year commitment. Now, of course, the longer you commit, the cheaper the instance is. So usually, customers do purchase some commitment plans on their own, but usually it will be in a low coverage, maximum of 40% coverage. And usually it will be a very flexible commitment plan, which means that the savings are not that high. I mean, they will choose the most flexible one, 1 year, no upfront savings plan. Now, of course, that if you will buy a 3-year commitment, you will generate much higher savings. Now, the reason why customers won't cover more of their environment and generate higher savings is because who knows what's going to happen in 3 years, right? Maybe a pandemic will hit again and I will have to scale down. Maybe I will want to change my machine type. Everything could happen. It's a long term, and customers would rather to pay more other than to commit for something that they're not 100% sure that they could stand behind it. And this is what we solve with 𝑒co. So 𝑒co is with 𝑒co, we will cover almost the entire customer's environment. It would be, instead of 40%, about 100% coverage, which means much higher savings because we cover almost completely. Now, we will cover with a diverse portfolio of commitments. We will do a combination of a 1-year, 3-year, different type of commitments. Now, the second thing we do is that we keep a lot of it sellable. So as you know, AWS has an RI marketplace where customers can sell and buy commitment plans there. So we have our own people there 24/7 that buy and sell commitments on behalf of our customers. Now, the second thing we do is that in addition to the public marketplace where everyone can buy and sell, we have also our own internal marketplace. So as we briefly said before, we have tons of big logos as customers, for example, Nike and AstraZeneca and Intel and AT&T. So if, for example, one big logo, let's say Nike, needs to scale down, automatically it provides a lot of other opportunities to the rest of our customers. So Nike will have the benefit of getting rid of something that was just costing them money and that they don't need, and we will trade it and we will move it to someone. For example, let's say on the buy side it would be Intel. So Intel gets the benefits of buying a 3-year commitment, which is the highest discount, on a 6-month term. So the idea is that we are able, because we have such a big customer base and data, so we can trade internally within our customer base and make sure that each one of the customer gets is being suited for the needs, for his specific needs. So that's the idea of eco. We will cover most of your environment with commitment plans, but you're not actually committing. Once you need to get rid of the commitments, we are getting rid of them for you. Now, last thing to say about eco is that eco is total risk-free. Eco by permission, by definition, by technical ability cannot create any downtime. It only manages the pricing layer. We do not buy VMs. We buy the commitment plans that is being put on the VM. So we do not see any code. We do not touch the infrastructure. Again, just make sure that you're being covered to the maximum with commitments, and by that we reduce your costs massively. So going back to the slide that I showed before, as you can see, each one of the products provide value for a different type of environment. Eco is, again, for stateful environments that are super sensitive, that cannot bear any reboot, that the customer says, I don't want to take any risk with spot instances, no matter what you say, don't talk about spot instances. Great, eco. I mean, we can deploy eco and everything. And the best part about eco that I actually forgot to say is that the proof of concept is immediate. I mean, the first thing that we do with eco, with a customer that is interested and he has a potential for eco, is that we first of all connect eco to his AWS account as a read-only. So we connect to his cost and usage report, read-only. We analyze internally the savings that we predict that we can generate to your environment right now. And by the way, it's gonna expand down the line, because eco lands and expands, and cloud, without even doing nothing, lands and expands. So we will analyze, and it takes 5 minutes to connect eco to your account, and within 3 days, literally 3 days, we will know to say this is the amount of money that we predict that we're gonna save. And then from that point, we just, instead of 5 minutes, we have a 30 minutes. We change it from a read-only to a full permission, and that's it. I mean, we start activating eco. We do a strategy call. We have some internal processes to do, but literally the proof of concept is 30 minutes. So that's the idea of eco. And going back again to Elastic Group and Ocean, so eco is for stateful environments. Elastic Group is for web applications, again, for EC2 instances, for everything that runs behind load balancer or on auto scaling groups. And the most advanced one, Ocean, is for containerized environment, which is, again, growing massively globally in the world. So the idea is that wherever you are in this cloud journey, at least one product could fit your needs. A lot of the times for example, we start with eco, and then 4 months down the line, we also put in Ocean, because each one attacks from a different direction. Elastic Group and Ocean are for stateless environments, usually, and mostly. They do have some capabilities for stateful as well, but mainly for stateless, eco for stateful, and together it's one holistic solution for your entire cloud environment. So to summarize the idea of the 3 products, here are the differences between how your cloud environment would look with Spot and how it looks without Spot. So let's start with how it looks without Spot. Normally, this is how a customer's cloud environment would look like. They will over-provision. Even when it's not necessary, they're going to provision more than they need. And usually, it will be a whole ton of on-demand instances, and they will be all of them the same instance type. So it will be very homogeneous. But as we said, you want your cloud to be flexible, right? You want to use diverse types of machines, diverse types of instances, And this is what we do with Spot. So with Spot, we will create the accurate blend for your own, for your specific individual cloud environment. At the base, we will put reserved instances with Eco, the FinOps product. And as we said, we will cover with reserved instances with commitment plans, but with no actual need to commit. On top of that, we will create a blend of Spot instances with different types of machines and sizes. If necessary, we will fall back to on-demand because we're able to. And by that, we're ensuring that you're always available, always scalable, always automated at the lowest possible cost. So basically the idea of Spot is that we reduce your costs massively. We reduce the burden massively. You don't need to take care of anything. We do it completely on ourselves, by ourselves, and then you have the time to take care of the real things that you would like to take care of. And eventually, by that we're doing both, we help you to accelerate your cloud adoption, to grow in AWS, to use more in AWS, and to use your money wisely, to help the same money that you were using and it was kind of wasting in a wise way that helps you to grow and expand and utilize your resources, as we said. The best part is that you're not paying anything as long as you're not saving. Spot by NetApp business model is success-based, which means that we're charging a percentage of the savings. And again, as long as you're not saving, you're not paying. So you don't need to put any budget aside for us. There's no additional fee. There's no need to guarantee for something. Once we start saving, you start paying, we're taking a portion out of it, as we said. So either way, you reduce your costs. And I mean, what it actually means is that we're that confident that we can generate massive savings because our whole, like the company revenue comes from savings. My salary is based on the savings that we're able to generate. So, I mean, we're obligated to generate savings because otherwise we wouldn't survive. That's the idea. I think that we have some time for some use cases to sum everything up. So for example, case studies, I'm sorry. So let's start with Ticketmaster. I assume that we're all very much aware of who Ticketmaster are. They are the biggest, I think, company that sells tickets for events and concerts and shows and whatnot. They migrated to AWS in 2017, and they started to be our customers. So Ticketmaster, I mean, they are selling millions of tickets on a daily basis, on a monthly basis. I mean, they're anywhere in the globe, right? I mean, they're the leader in this market. So they're used to sell a lot of tickets. And then COVID happened, right? So they were a customer of ours before COVID, and then COVID hits, and all of a sudden, everyone got into lockdowns. No one got out, no concert, everything is being canceled. And now all of the RIs, all of the commitment plans that they purchased, they were stuck with them. Now, what we were able to do with Eco, on one hand, Ticketmaster has no revenue right now because there's no shows and nothing is happening. But we also have customers from the gaming industry or from the pharma industry. And during COVID, they were exploding because everyone were sitting in their houses and they were playing video games. So we sold Ticketmaster unutilized commitment plans, and we shifted it and we moved it to these customers' environments. And by that, we also deployed, by the way, Ocean and Elastic Group, and eventually we helped them to get rid of the RIs that they wouldn't be able to do it on their own because it's much harder. And we were able generally to decrease their cost by up to 66%. We reduced the management overhead, and it was an amazing story. Duolingo, for example, is another customer of ours that I assume that you're all familiar with, a language education platform. So they also have millions of users, hundreds of millions of users around the globe. So they migrated to AWS, and they had to find a way to reduce their costs. So Here we deployed Elastigroup, and eventually we helped them to reduce in 65% their compute and to simplify their operations. Zalando, another example where they support more than 300 accounts on AWS, and they had to have to ensure availability and performance for these applications. And again, we were able to reduce costs, to optimize their environments, to simplify this and support, and amazing story. I think that we're a bit. I was talking quickly, but I'm done more than, I guess, just shorter than I thought. So I'll be happy to hear any questions if you have.
Question, if I can. At the beginning of the presentation, you've said that the transition from local data storage to cloud might be quite expensive. So how many clients resign at this point? They are shocked and afraid of the prices that comes with that, and they back off.
So basically, we meet them after they made the decision. I mean, we don't help them to migrate to the cloud. We meet them when they're already in the cloud, after they made up their mind. So we do not know what happened in the phase where people drop off in the middle. But I mean, that's the point, that people understand that even though it's really expensive, cloud has a lot of other benefits that on-premise wouldn't be able to support with. But we meet them at the point where they're in the cloud already.
Oh, okay. Thank you.
Sure.
So I have a question. So very nice presentation. Thank you. I'm working every day with AWS. So I'm wondering how we can try those products. What kind of model you have? Any GitHub repository? Do you have any work related with CNCF and this kind of thing?
So there are the few options that the sales cycle is very simple and straightforward. Basically, at the first meeting, we just meet and we discuss your cloud environment and how it looks like and what would be the best product that would suit your need. After we meet and we provide kind of a demo and we show you the console, there is a 2 weeks free of charge POC, where during the POC you already start saving money, right? I mean, so there's a 2 weeks POC where we define success criteria, we sync during the POC, and after this, basically we already, we sign a contract and we start deploying slowly with our solutions architect support, of course, one-on-one. We start deploying clusters, for example. We also have another option where if you would like to just play around with the products and not necessarily meet with our team. So we have a free user for, basically it's aimed for customers that are very small on the cloud. It's you can deploy up to 20 instances for free. But if you would like to get the sense of how it feels like, so you can start with deploying some instances on your own to understand how it works, and then to meet us. But eventually, I'm not exactly sure how big you are, but it is recommended to meet the team. We have a full team of account executives and solutions architects that take you hand in hand during the entire sales process, and we accompany you through the process. And also there's a few workshops and trainings that you can have, but I mean, only to get the sense. It's not really, I mean, it's not the. Was this understandable?
Hello. Yeah. I have a question regarding the licensing model.
Sure. Can you hear me?
The licensing model, do we have to agree for 1 year at least, or something like that?
Yes. So basically, yes, you need to I mean, you sign a contract that you're gonna be a spot customer for 1 year, but again, as long as you're not saving, you're not paying. So we can decide to minimize if you're not interested potentially and you're still signing the contract. So we will minimize our work on the spot instances, and we're not going to purchase any RIs if you're not willing to. And then, I mean, you're not actually paying because we're not actually saving, and it's on the paper.
Okay, and what is how calculated this base? When we are talking about the savings, is the start date or is the same period of a year before, or because if someone has the periods of Black Friday or something like that, and it cannot be compared.
So it's a great question. Basically, the way that we're calculating the savings is that we compare the on-demand price to the price that we were able to move you to spot instances. And the delta between these two is the saving that we were able to generate. So what you would have paid on demand and what we moved you to spot instances. At the price of this and the price of this difference, that's the saving.
Okay, thank you.
Thank you very much for this presentation. It was very interesting. I have several questions, actually. The first one is pretty simple. Is it correct that you care only about compute? Storage, network is not about this solution?
Yeah. So we're fully compute.
Okay, awesome. Next question, what about...
we have a new product that we're called Spot Storage that it's not GA yet, but stay tuned. But right now we are fully focusing on compute, but with a side note of Spot Storage that down the line would be relevant.
Okay, I see.
That storage, so that's what we
from NetApp.
Yeah.
I thought that NetApp, first of all, is about storage. The next question, what about serverless solution? Do you provide something for if I use Lambda, if I use Cloud Run from Google, etc.?
So Lambda, no. This is the use case where we cannot provide the services. But basically, yes. For the idea is that as long as you're stateless equal serverless, so we can provide the value. But Lambda is not applicable.
Okay, I see. And the last one, as I understand, you require that I run my serverless, I run my container on top of Ocean, on top of your Kubernetes cluster, not by my own. Is it correct?
Ocean replaced your autoscaler. So
instead of horizontal autoscaler, instead of vertical autoscaler, which one?
Can you repeat?
I need to replace Ocean by my autoscaler. I need to use Ocean instead of my horizontal autoscaler, instead of vertical autoscaler. Which one? I try to clarify the Ocean benefits.
So it's a bit. I'm not sure exactly to say the specific one, but the idea is that it replaces. Let me take it offline, and I will.
Sure. Thank you.
Thank you.
Okay, maybe one question from my side, or rather summarizing. Karen, you promised me to put a QR code at the end of your presentation, yeah? Please scan it. There will be 5 questions, and also one question will be, or at least 2 questions will be related according to POC, how to do it, and etc. If anybody is interested in, then we will contact with you and we will provide such a POC. So I just wanted to summarize it and clarify. Yeah. Thank you again, Karen.
Yeah, thanks, Karen. But we have a few more questions now from YouTube. If you don't mind, I will read them, and we'll give it a try. Yeah, if you could just show the questions, please. So Echo helps in analyzing the potential cost of optimization.
So basically, Echo not only helps with analyzing, it actually executes cost reduction. With Echo, we can save, I wouldn't say 80% like Ocean and User Group, but it could save 40-50% at least. But the first step that we do with Echo is that it's very easy to analyze before we even implemented the predicted savings that we can generate. So at the first step, we connect Echo, as I said. We analyze your environment. We understand the savings that we can generate. Once we start actually activating Echo, we start to save the money. So we're not only providing recommendations of how much you could save, we're saving. If it answered the question.
Yeah, I think so. Thanks, Karen. We have another question from Bartlomiej. Who is the owner of contract with AWS? The NetApp or customer who is covering an agreements, contract termination to, and potential costs related to such actions?
So basically, you can sign a contract directly with NetApp, with Spot, and you can also sign a contract through AWS through the marketplace, for example. So it's, I mean, yes, you sign in front of NetApp, but you could, if it would be easier for you, so we enable you to sign through AWS. But eventually, we're the it's between us, the end user and NetApp.
Okay, thank you, Karen. Are there any questions from the audience? Any more questions? All right. If not,
I just want, if there are any questions, so please feel free to reach out to me on LinkedIn or on email. I would be happy to meet you guys and to have like a one-to-one discussion and meetings. That's what I'm here for. So please, I mean, feel free to reach out to me anywhere in every channel that you would like.
perfect. Thanks again, Karen. That was a really good presentation. So now we will have a short break. So there is a pizza. So please we'll have like 5-10 minutes break when we will switch to another presentation. For people on YouTube, stay there. The pizza is not provided, obviously, but please be aware that in like 10 minutes we will start the next presentation, and again it will touch a bit on the costs. So we have like today topic about cost savings. Pizza is there. I'm not going to hold you much longer. There is also beer there on or in the fridge if you prefer to have it cold. Okay, thanks.
Thank you, everyone.
and we will start shortly.
One, two, three. Tak blisko muszę.
Blisko dosyć. Będzie zaraz może tak jest włączony.
One, two, three.
All right. We will start shortly the next presentation, and it will be about QA and optimizing costs. So please, if you could join us, that will be really, really nice. Okay, so the next presentation, as I mentioned before, will be also a bit, at least, about costs, and it will be delivered by my friends, by David and Aaron, and they will talk about termination of AWS resources. Yeah, without further ado, so good luck, guys.
Thanks, 𝙬𝙗𝙗 for the intro. And good evening, everyone, and welcome to our presentation on how to terminate AWS resources on an optimized cost in the QA world. First of all, today, as we celebrate International Women's Day, we would like to take this opportunity to wish you a happy International Women's Day and celebrate and recognize achievements and the contributions of women all around the world. If we switch to our topic, as we know, AWS provides a vast array of services that enable companies to build and deploy their applications at scale. But without proper management, it may become a costly burden on your budget, and that's where the optimization comes in. In this presentation, we'll be discussing the importance of the resource management and how to reduce AWS costs without sacrificing quality. We'll be exploring different methods of optimizing costs, from monitoring and automating resources in order to identify and eliminate the unnecessary ones. And by the end of the presentation, you'll have a better understanding of how to control the non-required AWS resources to ensure that they are being used to their fullest potential. But before we begin, we would like to take a moment to introduce ourselves. I am Erencan 𝘿𝙧𝙬𝙚, and I have more than 4 years of experience as software developer in test. Also, currently, I am trying to improve myself as much as possible in AWS area, and together with my colleague David, we are mostly focused on the testing activities in our team. And I pass it to David.
Hi guys, my name is David, and I've been working in Grand Parade for more than 4 years, and as a QA engineer since 8 years. And now with Aaron, we are responsible for testing AWS resources and applications hosted in AWS. And first of all, I would like to introduce you our project that we are currently working on.
But before that, let's take a closer look to our agenda today. And first of all, we are going to be talking about our project and testing approach to provide some context for our discussion. The main resource of the issue we were facing was caused by the testing approach, actually, and the need of the solution was existed mainly for us after that. That's why we thought that giving some overview about our approach would be beneficial to draw a clearer picture. Then we will dive into the matter of the issue, and we will introduce you the problem we were first facing with the leftover resource on AWS. And to tackle this problem, we have our project, Terminator, which we'll be discussing details. Then we will show you a demo how we use our Terminator project to kill our resources on the AWS. We are going to be creating anything on the AWS and we'll be killing it using our project in a live action. Then we'll be discussing the ways of maximizing the benefits you can get from a project like Terminator. And we will also delve into the topic of the cost optimization and how would hit to significant cost savings by using such an approach or the project, or how much you would lose if you didn't. And then we will wrap up with the Q&A session, and we will be happy to answer any questions you may have. And now we can just take a closer look at our evolution in our company in the recent years. As part of our projects, we have been evolving our use of AWS resources in the last recent years in Grand Parade, part of William Hill and 888. And specifically, we have been focusing on migrating from our on-premise cloud environment to AWS with the goal of leveraging all of the services that AWS has to offer. And also, we have been working on the increasing the performance and minimizing the cost of our performance test environment as well. Our approach was just to use the performance test environment at the best scale when we need it. But if we don't need it at all, we just scale it down, and which gives us the possibility to allocate our resources efficiently, and we keep our performance test environment at its best. And our approach to optimization is focusing on maximizing the use of the resources while minimizing the costs. And we believe that this approach helps us achieving our goals and improving our test environments.
Yes, so first of all, we would like to introduce our project. And this is the front-end part of our project. This is 𝘿𝙧𝙪𝙧 cash out, where you can cash out your bets. So for example, when you are making a bet, then you can withdraw your money. You think you did this bet, and you think your team won't lose. So you can cash out your bet, take your money back. So we are responsible for delivering live data to this front-end solution. And even if the match is in play, you can then cash out your bet. But of course, it depends on the result of the match. So if your bet is winning, you will get bigger money. And if your bet is losing, you can cash out like smaller money than your stake is. So that's why we need to have a very scalable solution, because sometimes we reach like 200,000 of customers during the match. So this probabilities of your win and the result of the match may change anytime. So like we need to process a lot of requests from the customers. And as you can see, the stake for our matches is measured in thousands of pounds. So we need to react very quickly and have a very scalable solution for this application. And this is how we do it. This is the project overview. We have several projects with this kind of diagrams, where this is this 𝘿𝙧𝙪𝙧 cache out. On the top right corner, you can see the AWS API gateway entry point when the requests are made from the front end. And the green services are the services that we are working on and we are testing. And the red ones are the external services, external APIs that we are connecting to and like taking the data from these services. These services are created also in our company, but by other teams. So first is the entry point on the top right corner. the customer is making a bet is making a bet, then the request goes to our first application, which is EKS container running in AWS. Then this container is reaching two external APIs, making a GET request, and then posting the data to another Kafka topic. And also, as you can see, it's reaching Redis Elastic Cache, then posting the data to the Kafka topic, and another application is informed and is consuming this data from this Kafka topic. Then this application uses DocumentDB, then posting to the next topic, and so on. This diagram shows how, I'm not sure it's complicated or not, but it's quite complicated, and we needed to have like very good performance of our application. So me with Aaron needs to test this solution. It's running in AWS, and this is the overview, and we will show now how do we test this and how we remove our resources. So this is our pipeline in the GitLab CI. As you can see on the left, there is a build stage. It's building the application, and we have there like lots of scans. These scans are delivered by our SRE team. For example, there is some security scans building our application, building our mock, because when we are testing our application, we build the mocks. This red application external APIs that I showed you on the recent slide are mocked by the Lambda, which we have, which is running over the API gateway, which is returning us the data which we want. And we don't care, we care about this data, but we have the contracts with the external APIs, the red ones that I showed before, so we can mock anything we want thanks to our Lambda and the API gateway. So this is the first stage, building, and then we are applying our resources. By the way, how do we create our environment? First of all, we have an isolated environment of our tests. So we run our tests in a dev environment, but we create each application separately, and each AWS we create separately. So each of these applications that I showed before on the slide are created with some, the name is like commit ID plus the application name or the dynamo or a table name or Redis name or something. So we create each application as an isolated. All the Terraform resources are applied in a Terraform apply stage. Then we are applying 𝘿𝙬𝙘. 𝘿𝙬𝙘 is creating our applications that are running in Kubernetes, and 𝘿𝙬𝙘 is a Helm charts as a code tool which allows you to automate the deployment management of your Helm charts from the version control. So after those three stages, we have our environment set up, and then we are running our tests, our component tests and E2E tests. And then what is the subject of our presentation? We are destroying our resources and applications running in Kubernetes. So after running the test, all the AWS resources should be destroyed. Also, sometimes the addition to that, like thanks to this solution, we can like have some continuous deployment and delivery made, because, for example, when the test passes, we can update the version of our applications running in dev. Yeah, in some projects we have this solution, not in everyone. Yeah, and this, and here you can see our test resources creation. So on the terminal, you can see our applications that are created by Kubernetes and running in EKS in AWS. And this is thanks to the 𝘿𝙬𝙚. This is thanks to the 𝘿𝙬𝙚 charts, which are delivered by our SRE team. So we have the charts delivered from SRE. We are like updating the version of our application and then deploying to dev with prefix with QA commit ID. So we know that this is our application and we need to run the test on these applications. So the 𝘿𝙬𝙚 is for the Kubernetes, and that and we also need to create the AWS resources. So of course we are using Terraform, and Terraform has the feature that when you are like pulling where you can pull the project, you can pull the infrastructure which may be created by our developers or cloud engineers, and we can update all the AWS resources with our names. So we are setting the variables for Terraform like QA commit ID, and then we have all the resources created for our tests with QA commit ID. So we have now full infrastructure created with applications running in Kubernetes and with each Terraform service.
Yeah, and to sum up, what we are doing is we are just creating our own stack with the snapshot versions or whichever we want, and we run our tests in an isolated environments. And of course, there are some advantages and some of the disadvantages of this solution. And let's take a closer look to the advantages first, and let's start with the pros. And there is no dependencies to other teams, data, applications, services, configurations, and etc. So we just create whatever we want and however we want. And if there is any need to get some response from the external services, we mock it and we know what's happening already. And the error is guaranteed to be pinpointed easily because we know what's going on. It's under our control and everything is created by us already, and nobody's touching the data in that. Nobody's changing anything. Nobody's killing any resources, and etc. So we know what's going on in this stack in the isolated environment. And it also gives us the quick access to results, which also enables the continuous deployment. And there is also another unique chance to have this approach is that you can even use this environment as your demo area. So you can create your tech stack with the applications you choose. And then if they're not even completed fully yet, but if you want to show something at the end of the sprint, or if you want to get some confirmation from the others, you can just spin them up. You can show the feature that you want to show, and then you can get the confirmation, you can get approval, or you can just keep going with the future development. On the other hand, there are, of course, some of the cons as well. And the main one for today is that the resources, AWS resources, might remain alive for any reason for a long time if you don't handle it. It is written in bold because of that. This is our main topic for tonight. And there are also some of the others. It can be time consuming. So when you are trying to create the environment, so it can take for some specific services up to 10 minutes. But of course, you can have some workaround on it. And you need to rely on the contracts for the external teams. Well, yeah, we generally do, mostly do. But in this case, if you don't check it later on, we do check it. But if you don't, and if you just try to rely on it, or if you don't want to spend on time, you need to see the real integration with the external services. And the last one is the complexity. Why is that? Because you need to deal with the infrastructure as code part as well. And if you did it on the normal dev environment, you would just deploy the applications and you would run the tests, right? But in this solution, you also need to have the correct infrastructure as code. You need to maintain it. You need to adjust it later on, and etc. But we think the advantages outweigh the disadvantages of the solution because it gives us the unique opportunities on our testing activities. And why would the resources be leftovers on the environments? The main two reasons for us was the forgotten jobs, which are never get triggered again, and the failing jobs on the destroy stage. The forgotten ones can be because of that we might want to check something on our environment, and we could cancel the destroy phase and then forget to trigger it again, basically. And I think we've all been there. And another one is the failing jobs. It can be for any reason, but for example, if it happened because of the pods on the GitLab, and if you couldn't trigger again successfully, so it can stay alive. And even if what's the reason, if there is any risk for your resources to be alive, to be blocker, or to be costly on your company, you need to deal with it. And there are some of the resources that we are using and we are creating while our testing activities. And this is not the whole of the list. For example, when we consider document DBs, so there are many different things like document DB cluster, cluster instance, parameter group, subnet group, and etc. So it can be much bigger list. And now we can just have a look at our Terminator project. We can have an introduction, and then we will have our demo session to show you.
Yeah, let me introduce you the Terminator project. This was the project that we created to manage our leftover resources. And the idea behind that is to provide the cleanup, to clean up these resources, so we don't have to worry about them and clean up them manually, like, logging into AWS, checking where this resource is and removing it, because it can be like costly for company, and also it takes time, right? So this project is running based on Python and uses Boto3 library, which is AWS SDK library for Python. And one of the key advantages of using this Terminator is, as I mentioned, reducing the manual effort of managing those resources. So it also saving our time, right? So we are running this project in a GitLab CI. This project is running on a daily basis each night. So for example, if some of us will forget about like killing our environment, this project is running at night and removing everything, what it finds and how it is checking those resources that it needs to remove. We have set up our regex, which Terminator is scanning and removing only AWS resources with this regex. And it is worth to mention that it's running only on dev. We don't run this project on production, of course. Yeah, so it's safe and secure because we're using regex, and there are also some potential side effects, but mainly at the start when you are starting developing this project. So you need to set your regex when you need to be careful because you may remove something wrong. But as I mentioned, we only use it on our production, not production, but dev environment. So we take care of not touching anything from production. Yeah, and also it might be a disadvantage, but for example, when me and Aaron are testing some new feature, new version of the application, he can create one environment with his version of application, and I can create another. And if someone of us will like run the Terminator project, he removes everything, not only his project, his resources on AWS, but also like my one. And more about Boto3 library. This library is, as I said, AWS SDK for Python. It's really easy to integrate with the Python and have a big support for AWS services, because we covered all of our services that Aaron mentioned, but the only service that we couldn't cover with this were Kubernetes namespaces. But this Kubernetes namespaces, we have the another solution for that. But Boto3 is really easy to configure, as well. As you can see on the left side of the screen. This is only needed for setting up Boto3 in Python, where you can where you adding the access key for your AWS account, and also secret key, but this token is not needed, I think. And then you can like import the resource, for example here S3, then run on it quickly some commands. So this code is like letting you running any command on any of the AWS resources that Boto3 is supporting.
Now we can take a look at the documentation of the Boto3 and our implementation to see how straightforward and easy it is to use and configure in your projects. On the left-hand side, you can see a snapshot from the Boto3 library documentation, and we can see that just the delete db cluster parameter group method, and which requires the parameter group name as a string as a parameter for this method. So you can see the request syntax, you can find what is required to be passed, you can see which method you need to use for it, and the returns and the potential exceptions. And on the right-hand side, we are going to be seeing details in the demo part, but you can see that there is a delete method that we are using, and in this delete method, we are exactly using this delete db cluster parameter group by passing the parameter group name inside of it to delete the specific of them. And in order to just make it more accurate and to delete the resources that we desire and to identify which are the unused after our test executions, we are just passing some regex to filter for the gathered name of the parameter groups, and then we remove them. So if we can just show it in an action with the demo session. And what I'm going to do here is I'm going to just create again, document db parameter group, which is easy to create and to delete after it is created. And just takes a couple of seconds, and that's all. And I'm going to give the name AWS User Group here for our resource. And I'm going to create it. And we can see it. It is here. Total number of the parameter groups is 7 at the moment, and we have our AWS User Groups on. And when we switch to our Terminator project, on the main part that we can see, as David was explaining, that the session part. So we are creating our session and then passing our client class for removing and delisting our resources. Then given our regex configurations and also the batch size, I'm also going to be talking about it, and the sessions. Then we'll be running the listing and the deleting methods for each of them to clean the resources. But for it, we are also passing this config file, and on this config file, so this is normally like this. So what we are doing is when we are creating our resources, we are adding this QA and commit ID, which is including 8 number of alphanumeric things as a word, and then we are filtering with it. Sometimes it is different, but we are trying to find the most specific one in order to not to affect anything else. And on our class, the client class, we are just creating the low-level service client with the document DB, which can be easily found again on the documentation of 𝘿𝙬𝙬 library. We are given the regex and the batch size from our config file, and gathering all of the parameter groups in the beginning. Then we filter them based on the regex. Then we pass those with the delete DB cluster parameter group method, which we already saw on the documentation of the 𝘿𝙬𝙬 library. And when we just run it with the one line of the command. Okay, so let me change the spec to AWS User Group. There is nothing on the QA/8 commit ID at the moment, so we saw that it didn't delete anything that we didn't want to. So after changing this to AWS User Group, we see that deleted this one, and on the AWS side, yeah, it is removed, and there is also the 6 of them, which is the desired behavior. And there are also some ways to get more benefit from Terminator, and we'll be talking about it now.
Yeah. So of course, we have added the scheduler for our Terminator, and it's running in GitLab CI. It's scheduled each day at the midnight, and then it's removing all the resources with 𝑄A-commit ID. So you don't have to run it in a GitLab CI. Of course, you can run it like in Jenkins or as a Lambda function. Before that, we ran it in Lambda function, but Lambda has a maximum timeout like 15 minutes. And when we moved to Python, we did it. We changed it to a GitLab. As you can see on this terminal, we are logging each resource that is deleted, and also we should maintain this project because sometimes you can see something strange in the logs, so you need to take care of it. And like each project, this is also needed to be maintained. Yeah, and also it's good to mention that the timing of this Terminator, because it's like 2 or 3 minutes, and we have everything removed. And one issue we faced was also like removing the dependent objects, because sometimes you cannot remove the object that is depending on the like hierarchy object. For example, like Redis and Redis parameter groups. So you can't remove Redis if you don't remove the Redis parameter groups. So the order of removing the resources is also important. First, you need to remove Redis parameter group, and then you are allowed to remove Redis. And cost optimization. So we were able to decrease our costs because like the cost of Redis is $0.2 per hour. So if we kept our environment only for Redis, we would pay $200 per month and $1,400 per year. So now we are safe because we are running our Terminator, and then each night all the resources are removed, so we don't care about the costs. So this is one of the examples, but we have DynamoDBs and a lot of AWS resources.
Yeah, so we can also imagine that, let's say we had 5 different test projects, and averagely they left like 5 times in a month, right? Okay, we destroyed them, but for any reason they remained alive 5 times a month averagely, which means 25 times. And if we say there are average 10-15 resources, which makes you 250, and increase the cost a lot. On the other hand, there is also another aspect, and it is that causes some limitations and which can be a blocker for you. For example, we've been talking about this parameter groups or the subnet groups. Let's say you have the limit of 50 for creating the parameter groups. And because of that, there are some of the leftover resources after the test executions, which is reaching to the top. So you need to extend or identify which are not unused and to remove them. So extending or identifying and removing them would take you a couple of hours, which might block your development or the testing activities. So to sum up, yeah, the testing approach, it gives us the unique opportunity to have a different view and also accessing the results quickly and etc. And of course, we had some disadvantages that we need to handle. One of the main of it was this one. And so far, we are happy with the results, and we think that we are not causing so much cost at least. I'm not going to say nothing, but I'm not going to say that it would be a lot. And with the help of the Terminator, of course. And we can wrap up the presentation with the questions if you have any of them now.
Any questions?
Thank you very much for this presentation. Actually, I have two topics to discuss. The second one, and it's more about your goal for this presentation. Actually, we use the same approach. We have the same, I would say, the same terminator in our project. I suppose it's a common case to terminate resources. About your terminator, are you going to publish it? Are you going to make it open source?
We didn't have any idea about it actually so far. We are using it internally to overcome the issue we face.
Actually, me too. No worries. And one more tips for you. We have a case when we need to keep this environment at least one night for several cases, for several internal cases. And we use labeled resources, and this terminator doesn't destroy this project if we label several resources. It's just a tips. How can we improve this approach? The second question is more about your pipeline, because actually you didn't specify the goal. Why do you use a specific project for your pipelines? Because if you make it for I would say for unit test, I don't see any reason to use a separate project. If you use it for performance test, it looks like it shouldn't be a part of pipeline. I mean CI pipeline. Probably it could be a part of CD. Could you please specify this part of your presentation?
You mean like a pipeline for our testing, right?
Yeah. It's about your testing, because you mentioned that you prepare environment, you deploy a new environment, you run several tests, you destroy an environment, and you deploy it to production. It looks like it's a part of CI process.
Yeah,
but in this case, I don't get why do you use a separate environment. You just could mock all APIs, and I suppose just you use microservice architecture, you can mock everything. Probably you can prepare a simple replacement within Kubernetes cluster, and that's all. Yeah. But you use a complex solution, because I remember your cons.
Yeah, I can take this question. Yeah. So generally, when we are taking this approach for testing our product is if we are creating a brand new product, which is going to be very flexible and needs to be checked on several aspects, and if it's a tech stack like this one, and if we need to check them sometimes one by one, sometimes in a whole stack, so we apply this approach. But if we have an application which was already been there for several years and which is working fine, so no need to create a separate environment each time for it, right? Because if you have the test running for it, and if it is stable already, you don't need to change the versions. You don't need to just spin up the new environment and etc. And the cache out for us was a brand new one, and it was very dynamic at this time. So we followed this approach. And for the performance testing, another answer for the question, we are having a stable environment, and which is having the configurations the same with the prod environment, and we are running our tests, the performance test on this separate environment.
Okay, I see. Thank you.
Thanks.
Any more questions? Do we have also questions on some questions on the internet? No. So yeah, if no more questions, thanks a lot for the presentation, guys. It was really nice. I enjoyed listening about the costs again. That was fun. Thanks a lot.
Thanks for listening and for your time.
Okay. So before we are going to finish and also finish beer and pizza, don't forget if you didn't sign up for the quiz, it's still a chance, and we will also give the gifts for the activity as well. Okay, we will give the gifts offline. I think that will be it. If you ask questions on YouTube as well, please leave the email address directly on our channel, and that will be it. Thanks again for the participation. There is one more thing that I wanted to mention for the AWS Community Day, if you could share that as well. So 1st of June, there will be again an AWS event in Warsaw that it will be in person. And it's a bit bigger event that all the communities from Poland, all the user groups members organize. It's a AWS Community Day that it will be for free in Warsaw, personal event. So if you are interested, there will be multiple tracks, multiple sessions. You are welcome to join. All right, we also have winners for the AWS credits. So we have AWS $25 credits, and I will just read the first part of the email. Who won? Give me a second. 𝙀𝙧𝙬𝙚 25, Michael 36, Małgorzata, Andrzej, and Antuyu. So congratulations to the winners. They will get on the email the voucher with $25 on AWS credits. Great, thanks a lot. Part for the quiz, and for the most active persons, we also have the gifts. Maybe Łukasz, I can ask you here for giving the gifts.
Did you notice who was the most?
Yeah, I noticed few people. Yeah, I mean that definitely.
But let's start from ladies. And I remember
of course.
This girl, yeah.
Yes, I think that will be the right choice.
In every bag it's the same, so congratulations.
Thank you very much.
Next, I think that this man.
Yes.
was the most.
Agree totally. Congratulations.
Third one was Andrzej. I know him.
Yes.
He asked about a few questions. And the rest, it's up to you, because I don't remember.
Right. I remember Marcin that asked a question, so I think that would be good to give him a gift as well. Thanks. Anyone else that we missed? If not, there were people also on the internet, so okay. Yeah, we will contact them if possible. Thanks. Yeah, I think that's it. Thank you very much.